Good afternoon, everyone. I am Roldan C. Bangalan, faculty member of the School of Arts, Sciences, and Teacher Education of St. Paul University, Philippines. My fellow attendees, I'm glad to share with you my paper titled Effectiveness of Writing to Learn Strategy and Students' Conceptual Understanding and Attitude in Pre-Calculus. The technological advancements and breakthroughs of the globalized world ushered in new knowledge, tools, and ways of doing and communicating mathematics. Mathematical competence has become imperative not only for basic and ordinary day-to-day routines, but more importantly, for better functioning in the society. The ability to understand and manipulate mathematics paves for countless opportunities to comprehend different perspectives and world conditions, and to engage in disciplines that shape one's future. To maximize these opportunities, it is necessary for an individual to equip himself or herself with mathematical competence. A strong foundation in mathematics is necessary to the progress of science, technology, and engineering, which economic development for a country greatly relies on. Kajuru and Bello from Africa pointed out how economic development in a country could be achieved through mathematics. Similarly, George and Thomas Kuti of India reiterated that mathematics plays a very important role in the modern world. The Washington Council of Chief State School Officers and Texas Instruments Incorporated stated that mathematical literacy is vital for the nation's economic growth, security, and civic progress. In the Philippines, the roles of mathematics education, as stipulated in the mathematics framework for Philippine basic education, include facilitating participation in productive life activities, providing a way for making sense of the world, serving as a means of communication, and operating as a gateway to national progress. It is therefore necessary for educators to enrich their students' mathematical experiences as they give them the gift of a high-quality mathematics education. Educational organizations and researchers advocate the use of writing in mathematics. The National Council of Teachers of Mathematics strongly recommend that this process of writing in mathematics become an integral part of mathematics lessons. NCTM has asserted that writing in mathematics courses not only gives students a chance to communicate mathematical ideas, but that doing so deepens conceptual understanding. Brunner advised that both writing and mathematics are devices for ordering thoughts about things and thoughts about thoughts. Vygotsky postulated language as a powerful tool to learning. Lim and Pugali also stated that language and writing are essentially connected. They added that language plays an important role in developing students' conceptual understanding in mathematics. In the university, it is a common classroom observation that senior high school students could hardly explain their thought processes in solving problems in mathematics. Mathematics teachers found out that majority of the students have difficulty in answering items in their quarterly exams which require higher order thinking skills. Mathematics teachers could hardly call on all students to recite and make students' thinking visible. Mathematics teachers, therefore, need to explore effective and innovative ways of making mathematics learning more meaningful, more interesting, and engaging to allow students to communicate their thought processes and think through key concepts. These may be realized through the use of writing to learn strategy. Writing to learn strategy is a strategy through which students can develop their ideas, their critical thinking ability, and their writing skills. Writing to learn activities are short, impromptu, or otherwise informal writing tasks that help students think through key concepts or ideas presented in a course. It is for these reasons that I investigated the effectiveness of writing to learn strategy in the teaching of pre-calculus, particularly in enhancing understanding of mathematical concepts and processes among grade 12 students of St. Paul University, Philippines. This study specifically sought to answer the following questions. What is the level of conceptual understanding of the participants in the pre-test and post-test in terms of the following competencies: ability to identify and apply key ideas, and ability to draw inferences? Second, is there a significant difference in the pre-test and post-test scores of the control and experimental groups? Third, what is the participants' attitude towards mathematics before and after the implementation of the writing to learn strategy in the control and experimental groups? Fourth, is there a significant difference in the participants' attitude towards mathematics in the two domains, mathematics in general and writing in math class? Fifth, what are the challenges, realizations, and suggestions of the participants after being exposed to the writing to learn activities? And sixth, what plan of action can be proposed to effectively integrate writing to learn strategy in teaching mathematics? This study employed the quasi-experimental method, particularly the pre-test post-test group design. The participants of this study were grade 12 STEM Set A students of St. Paul University, Philippines, enrolled in pre-calculus during the first semester of the school year 2018-2019. The study utilized a researcher-made questionnaire which underwent content validation by mathematics experts. A content validity index of 0.9125 was computed. The attitudinal survey of RHEI was used to determine the students' attitude towards mathematics. Three open-ended questions were also included to determine the challenges, realizations, and suggestions of the participants and the use of the WTL strategy. In this study, I utilized the following types of WTL activities, which are categorized into two: aptitude assessment through reflective writing and content assessment through expository writing. Reflective writing activities include mathography, admit slip and exit slip, free writing, Madias point, think, write, pair, share, and learning lag. Expository writing activities include word problem, process log, and summaries. The data gathered were analyzed and interpreted using the following statistical tools. To interpret further the mean scores in the pre-test and post-test, the arbitrary scale was used. And likewise, for attitude, this arbitrary scale was used. These are the findings of this study. These data indicate that the participants, both in the control and experimental groups, have a low conceptual understanding of pre-calculus before their exposure to the treatments. Tita's result reveals that the two groups are comparable with respect to their conceptual understanding of math concepts before their exposure to the strategy. Participants in the control group had a high level of conceptual understanding in the post-test, while those in the experimental group were rated very high. Tita's result implies that the participants in the experimental group have significantly higher level of conceptual understanding than those participants in the control group. Data show that the level of conceptual understanding of the participants improved from low to very high. It implied that the post-test mini score of the experimental group is significantly higher than that of their pre-test mini score. Furthermore, the use of writing to learn strategy is effective in enhancing students' understanding of pre-calculus concepts. These data imply that the two groups are comparable with respect to their attitude in terms of mathematics in general and writing in math class prior to the utilization of this strategy. Participants who were exposed to the writing to learn strategy have the same level of attitude in terms of mathematics in general with that of the participants who were exposed to the lecture discussion method. The attitude towards mathematics in general of the participants did not improve significantly after their exposure to writing to learn strategy. However, participants' attitude towards mathematics in terms of writing in math class differs significantly before and after their exposure to writing to learn strategy. In a 6-week exposure of the participants to writing to learn strategy, they encountered some challenges. The main challenge encountered by the participants when using the WTL strategy in learning pre-calculus is limited knowledge of math vocabulary. In addition, limited time to work on the WTL activities and difficulty in expressing one's ideas through writing are considered by the participants. Being asked about their realizations in using WTL strategy, the participants revealed that the WTL strategy helped them understand mathematics concepts better and allowed them to express their thoughts and feelings. In order to improve the implementation of WTL strategy in teaching and learning mathematics, participants suggested that they should be provided with sufficient time to work on the WTL activities. In addition, they also proposed teachers to give more examples of solving math problems before asking them to work on WTL activities. Here are sample students' WTL output. Mathography. Admit slipped. Exit slipped. Free writing. Think, write, pair, share. Word problem. Process log. Summaries. Learning log. The findings concerning effectiveness of WTL strategy, the challenges pertinent to its utilization, and the realizations experienced by the student participants serve as a basis for the development of this plan of action. This is the developed Writing to Learn support material. It includes teacher's guide for integrating WTL strategy in class, the what, why, and examples of writing to learn activities, and the rubrics for assessing students' WTL output. This material was shared to my fellow math instructors in the university. I also encourage other faculty members to integrate writing to learn strategy in their respective classes. Based from the findings of the study, the following conclusion was drawn. The exposure of the participants to the writing to learn strategy resulted in better performance. WTL strategy can enhance students' understanding of mathematical concepts. In using writing to learn strategy in the classroom, mathematics learning is facilitated as students are exposed to learning activities that foster critical thinking, problem solving, reflection, and collaboration. Students learn best when they are engaged in activities that lead them to think, discover, reflect, and share. WTL strategy, therefore, is one of the various effective strategies that mathematics teachers may employ to enhance students' motivation, enjoyment, and performance in learning. You may also utilize this strategy in your own online classes. Thank you. Diyos magbalo.